In this problem, I've got a crate. It's 40 kilograms pulled by a rope as shown. I want to find the coefficient of static friction between blah, blah, blah. That should be an alpha. It's not the best alpha. Uh, Determine the magnitude of the force for impending motion. Okay, so we're going to start with our free body diagram here, which I'll draw right below here like this. Okay, and I don't know what P is. That's what I'm really trying to find. Okay, so I'll leave that like that. But this angle is 40 degrees as shown there. Okay, I also have the weight of this guy acting right at the center. Okay, so that's going to be 40 times 9.8 because it's kilograms. I need to convert it into newtons. Okay, now what happens is when I have a rigid body with some dimensions and I pull on it, okay, I have a friction force that gets applied opposing that motion. Okay, and again, what happens when I do that is I create a couple moment between that applied force and the friction. Okay, and what needs to happen then is I need to balance with another couple to keep this thing in static equilibrium. So what happens is my normal force moves over some amount. Okay, and I'm going to set the distance from the center to be some amount x that it moves over. Okay, if n gets all the way off, then it tips over. If n stays there, then it will just slide. Okay, so here's my free body diagram. We're going to go ahead and start writing my equations of motion. Okay, so I'll sum the forces in the x direction. I'm going to have my friction force, and I'm going to have P cosine 40, and that'll be it horizontally. Vertically, I will have P sine 40. It's going upward, so it's positive. I also have my normal force N, and then I have my weight, which is mg, which is 40 times 9.8 as shown there. Then I'm going to sum the moment, okay? I always typically sum the moment about the point right below my gravity, so I get rid of that. I will also get rid of my friction in this situation, and the only thing I'll have is that negative x times n, okay? And then I actually have two components due to p, right? I've got a horizontal and a vertical, so I'll take the horizontal distance of 0.4 times the vertical force, which is P sine 40, and I'll recognize that creates a positive moment, okay? Then I'll take the height of that thing, the vertical distance of 0.5 times the horizontal component, which is the cosine 40 of P. That is also a positive moment, so I'll throw that in there like that, and I'll set that equal to 0. Now, if you recognize at this point, I have 1, 2, 3, 4 unknowns. So I can't really solve this at this point, okay? But I recognize that what I'm looking for is impending motion, okay? So there are two types of motion. I just kind of alluded to it earlier. This thing can either tip over, right? Friction's large enough to keep it in point until I pull hard enough that it tips over, or friction can't really hold and it just slides across the floor, okay? So we'll start with the slips. We're going to solve it both ways and then determine which one actually occurs. So if this thing is going to slip, that friction force, okay, and again, I'm looking at the point right before I'm impending motion, so right before this thing starts to slip, that friction force is going to be at its maximum, which of course is going to be mu s times n, which for this problem is 0.35 times normal force, okay? So using that equation, okay, I can solve those equations above and find that P equals 138 newtons, okay? This basically gives me, you know, if this is equation 1, this is equation 2, this is equation 3, this gives me a fourth equation, okay? And then solving those equations, I can determine what my P is, okay? Now, I don't necessarily know if that's the answer because the other thing that could potentially happen that I've got to check out is tips, okay? And if this thing tips, what I know, again, this is the point right before it tips, basically n can move over all the way up to x equals 0.4, okay? At x equals 0.4, the normal force can no longer shift over anymore, And what happens is this thing actually starts moving. At that impending motion, it's tipping. So this is essentially my fourth equation now. Okay. Using that along with the three equations above, I calculate that P equals 175 newtons. So now the question becomes, okay, well, which one is it? Okay. Now, if I think about this as I'm applying my force, increasing, I start at 1, 2, 3, 4. I keep pulling on it. Once I hit 138, that thing's going to start slipping. I never get to the answer that's tipping. Okay. But I need to prove that to myself. And as with most friction problems, you have to either solve and prove an assumption you've made, or you need to solve, make sure it's below the maximum, or you need to solve it two, three, or more times in order to actually figure out, which one is occurring. And this is the case on this one.